All right. So grab, like I said, grab your book. You have a book, I think, right? All right. Quick repeat of last week. Is there anybody out there that doesn't have a book? You got yours, okay. Here's the deal. Nate, please do your best to kind of listen to the first 5 minutes because I'm just repeating. Guys, if you look at your book, I did page 1, 2, 3, 4, 5. I did the first 5 pages, and then I turned you loose, okay? Well, let's talk about the first 5 pages. I started by talking about classifying, hang on one second. Classifying polynomials by terms. If I say you have a monomial is how many terms? One term. Okay, so just one term, such as what? 2x or 3x. Okay, there you go. I'm just repeating. You don't even have to be on any page. Okay, so what's a binomial? 2 terms.
Nice.
Okay. 4x squared. How about that? Plus 10. That's a binomial. Trinomial.
3 terms.
3 terms. Okay, so 3 terms. 6x squared minus x minus 20. How's that? Good? Okay, so you can classify polynomials by number of terms, and then you can classify them by name. By name, what is this? A polynomial of just 6. What do we call that? That's called a constant. It never changes, it's always the same number. Constant. What about this? 6x to the first. You call it what? Linear. 6x to the second. Quadratic. X, 6x to the third. I'll just keep going with 6. Cubic. And 6x to the fourth. Quartic. And Dylan, you got questions?
No.
Okay. Dylan, what's that? What's this? 6x to the fifth.
That's quintic.
Quintic. Okay. Okay, there it is. Now, hey guys, I made these way too easy because I just said one term. But I can disguise it and go like this. 5 plus 6x cubed minus x squared minus 4x.
But isn't that set up wrong?
What's that?
Isn't it set up wrong?
That is set up wrong, but can I ask you this? What is it by name?
It's a trinomial, or not
It's a
trinomial.
quintic.
It's
Quintic.
a
Polynomial.
Okay, it's
Quintic.
quintic. Why'd you call it quintic?
You have to add them.
Nope. Nope, you're supposed to look at every term and pick the highest term. Which term?
size from
Cubic.
3.
Right there, 6x cubed, so it's what? This is a cubic polynomial of how many terms?
4.
4. Is 4 terms binomial, monomial, trinomial? No. So we just call it a polynomial of 4 terms. Okay, we
So
said
when do we add them?
oh, that's if I said what's the degree of the monomial, and I went like this. This would be a situation where I said, what degree term is this? This is just one term. All you do is 2 plus 3, it's a 5th degree term. This does not happen very often. Matter of fact, they just wanted to tell you this, but we're not going to deal with that, so you don't have to worry about that. All you have to do is pick out the highest degree term. And the highest degree term is whatever x to whatever power that you see as the highest power. Okay? All right, so we can classify by name, linear, quadratic, by terms, binomial, trinomial, or we can, that's all we did. But like Noah was saying, that last problem I showed you was not in what form? Standard. So really, guys, I might ask you guys to do this. Take this, put it in what form? Standard form, which just basically says, give me the highest power of x. So that would be what?
6x.
right there. That would be first, 6x cubed, followed by
X squared.
minus x squared, followed by minus 4x. Finally, what? Plus 5. That's standard. That was part of your homework, wasn't it?
Yep.
Yeah, okay. All right, next step. End behavior. End behavior. All right, so how does your polynomial act on the left side? How does it act on the right side? Well, there's two types of graphs. Or I should say two types of polynomials. There's even, and then there's odd. Okay? So let's go with even first. Even says if you have x to the second, or x to the fourth, or x to the sixth, or x to the eighth. If the number in front is positive, this is called the leading coefficient. If it's positive, it acts like a parabola going which way? Up, up. So what you say is this, on the left, it goes up. On the right, it goes up. What it does in between, I don't know unless I start plugging in points or values for x. So what is it doing in here? I don't really know. Okay, this one, if I went like this though, negative 2x to the fourth, again, 4 is even. This is an even polynomial. Leading coefficient is now negative versus positive. What's it gonna do? Now it goes down on the left, down on the right. What it does in between, I don't know. I mean, it could actually do something like this. And that's how crazy these polynomials get. I mean, we'd have to do a lot of work to get that piece. But here's what I know. Down on the left, down on the right, up on the left, up on the right. The key thing is, look at the leading coefficient. Positive, up, up, negative, down, down. Right? Are you okay with that? Next, odd functions. Odd polynomials are x to the third, x to the seventh. If this is negative 2x to the third, what do odd functions act like?
Down, up.
Well, but I said they act like something. Like even functions act like parabolas. What?
A line.
A line. This is a line that goes which way? This is a line that goes up. This is a line that goes down. Now, if your leading coefficient is negative, you have what line?
Up or down.
You have a line that's going down. So here's the end behavior. Up on the left, down on the right. So you'd say this one goes this way, followed by this way. Now, what's it do in between? I don't know again. I mean, it could do something like that. Who knows? All I care about is what? What do I care about?
Down and up.
The end behavior. On the left, what's it doing? On the right, what's it doing? Okay, this one, I'll make this one positive. I'll make this one positive 5x to the seventh. A positive leading coefficient means the line acts like what? Up. This is the line. Now what's it doing on the left?
Going down.
Down and then up. So down on the left, up on the right. What's it do in between? I have no clue. No clue. This is a big, big question mark that we'll figure out later. Okay? All you had to say was down, down, up, up. Or you might say what? Up on the left, down on the right, down on the left, up on the right. Okay? So here we go. Nate Battles, I'm going to quiz you right now. Can I do it?
Do it.
Okay. X to the eighth, negative 5. Nate, is this even or odd?
Even.
Even. Leading coefficient is positive or negative?
Negative.
Negative. Okay. Even functions act like lines or parabolas?
Parabolas.
Okay. Is it going to go up, up, or down, down?
Down, down.
How come?
This is the leading coefficient is negative.
Yeah, he got it. So he should say down on the left, down on the right. What's it do in between? We don't know. Okay, there it is. He got it. He wasn't even here on Friday. Are you okay?
Yeah.
Okay. Page 1, 2, 3, 4, 5, our time. 4, 2, 6. Here we go.
Is that terms?
I have a question.
Yes, it is terms. Yes, go to terms. Your question is?
Just kidding.
Just kidding, never mind. Okay. All right. Alright, so you guys are seeing this, right? Right? Turns? It says, the graph of a polynomial of degree n has at most blank turns. Okay, I don't really expect you to know the answer until I show you something. Tell me this. X to the second degree. If I graph x squared, what do I get?
No.
You get a parabola, yeah. You get this. This is what you get. So you tell me, how many times did x squared turn?
Once.
Once, watch. Down, 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 and it turns and it goes up. So it turns, this is a turn, it turned once. Okay? Now, if you have second degree polynomials, it will turn how many times?
Once.
One turn. One turn. Okay. If you had x to the first, linear. Guys, do you remember a linear function is just a what? It's just a line. How many times did this line turn?
0.
0. So x to the first has 0 turns. X to the second has what? 1 turn. So what would x to the n have? How many turns? Yes, ma'am.
The quiz key from that filing from last week.
Okay. Wait, hang on. I think I put it back in. Did I?
No.
No. Okay. Then try this. Quizzes. She's correct me one last time.
I can just get it later.
Okay.
No worries.
I thought I put it back in there, to be honest.
I don't-
Okay, sorry guys, sorry. Listen. How many times will this one turn?
N turns.
So you're telling me
Many turns is a-
n turns, but here it was x squared turns once, x to the first turns 0.
No, because it doesn't have a number.
Turns M.
Okay, wait, watch. X to the first did not turn. X to the second turned once.
It turns one less than the number is.
Yes, it turns one less than the number is. So he says 2 will turn 2 minus 1 once. 1 will turn what? 1 minus 1, 0.
That's why I said M.
What is this going to be?
Good point.
N.
Quick thinking.
N. Minus 1. That's all it is.
Yeah.
Whatever number this is, I don't care what number that is. Just take away what? 1, and that's how many turns you make. N minus 1.
So how many turns is it?
We don't know because do we know this number? No. But if we knew the number, let's say it was x to the 10th. Sorry, get rid of the 1. How many times would x to the 10th turn, guys?
9 times.
Yeah, all you have to do is take that number, 10 minus 1. It turns what? 9 times. Okay? This is a generic number, and we don't even know what number that is. Just take that n, that variable, subtract 1, and that's how many times it will turn. Okay? Alright, look at the bottom. If you look at the bottom, it says, hang on, I'm trying to get to myself. Okay, on the very bottom it's got some examples. It says, if you have a line that's linear, 0 turns. If you have degree 2, it's quadratic, 1 turn. Look at degree 3, guys. Are you looking?
Yep.
Okay. Degree 3, it says you could turn what?
0 or 2 times.
Right. So watch this. X cubed could turn 3 minus 1, 0. That doesn't make sense. 0 minus 1 is what? 2 turns. But wait a minute. There's a little kicker here. If it could turn 2, it can also do this. Take your answer 2 and always subtract 2. It could turn twice or it could turn what? 0 times. Okay? Does that make sense? So now watch this. X to the 5th could turn, say it,
4.
4 times.
4 times. 4 turns. Or what?
0 turns.
2.
Subtract 2.
Why is it?
The rule is it's every other.
Okay.
So subtract 2, what do you get?
2.
It could turn 2, or subtract 2 again, what could it do? 0. So x to the 5th could turn 4, 2, or 0. X, let's just throw one more at you. X to the 12th could turn what? 11 turns.
9.
7, 5, 3, 1. There.
Every other?
It's every other. It's always subtract 2, subtract 2, subtract. It's every other. Now, what's the most it can turn though? The most. 11 times. Then it can't turn anymore. Okay? Alright. Go to the next page. Yeah, now you gotta actually do something and think about it. Okay.
We already did it.
State the number of turns possible. Ready? Yeah, I know I did. X to the 5th minus 4x plus 2. How many times could it turn, Caitlin?
4, 2, 0.
4, 2, or 0. Did you write that down? 4, 2, or 0. Good. How about number 2, Dylan? Arhus.
Which one?
Arhus.
Yeah.
Number 2.
Yeah.
Number 2. I know you don't, because I can see you staring. Come on, stay with me. What? How many times could it turn?
Twice.
2x squared minus 4? What's the rule?
One time.
The rule is to subtract 1. Yep, 1 time it could turn. That's it. Hey guys, if you take 1 and subtract 2, you get negative 1. Can it turn negative 1 time?
I guess no.
No. So just once. Okay, now look at the bottom. State the number of turns that you see, and then tell me what degree it could be. Okay? Give you 10 seconds just to look. Noah, how many turns do you see? How many turns?
3.
3. Okay. Noah, what degree could it be? Watch this, guys. 1, 2, 3. He was right, but what degree could it be?
4.
He says 4th degree. Is he right?
Yes.
Because x to the 4th could turn what? 4 minus 1, 3 times. He was right. But, you know what? It could also be this.
So,
It could be x to the 6th. How come?
You can go down to 2.
You keep going down by 2's. So this could be 5, 3, 1. See, 5, 3, 1 fits here too.
Wow.
This could be x to the 8th. How many times will x to the 8th turn? 7.
Why is it 5?
Why is it 5? One less than this is 7. And then you always subtract 2. Subtract 2.
No, I'm talking about 6. Why did it go to 5?
Oh, 1 less than 6 is what?
Oh.
5, 3,
Good degree.
1. So right there, see that 3? 1, 2, 3. This could be x to the 6th. This could be x to the 8th. But here's the deal. All I really care about is what's the least degree it could be? X to the 4th. That's what you have to do. Just give me the least degree. Don't give me any option. Oh, by the way, what's the secret here? Take the number of turns and do what?
add 1.
Add 1, and then you get to 4 and you're done. Yeah. Yeah, Skylar?
When you say least, you mean minus 1 on the power? Would that
No, what I mean is this. Like this graph could be x to the 4th, x to the 6th, x to the 8th, x to the 10th, x to the 12th. I just want the least degree. It could be, that would be this one. I mean, any of these are right. I just want the least degree. Just add 1. Add 1 to your turns and call it good. Okay? Okay, turn the page. Here we go. Next up. It would say, does it say factor theorem?
Polynomials, linear factors, and zeros.
Okay, polynomials, linear factors, and 0. Here's what it says. What is this factor theorem? There's something called the factor theorem. It says the expression x minus a. Okay, so when I say x minus a, think x minus 5 or something like that. X minus a is a linear factor of a polynomial if and only if the value of a is a, what does that say?
Root.
Okay, a root. of the related polynomial function. Cross out the word root, because we haven't really said much about what a root is. So cross it out and put this. Cross it out and say this to yourself. Is a 0, or you could say what? Solution. This will make a lot more sense to you, because we don't talk that way. Okay. Right on the bottom of that paragraph. Okay. We don't talk this way. This is Algebra 2 talk. A root is basically a 0 or a solution to your polynomial. Okay. Then I talk about this. Multiple 0. If a linear factor is repeated in the complete factored form of a polynomial, the 0 related to that factor is a multiple 0. So now, let's go look at what they have. They have this. 2x times x minus 3 squared, okay, equals your polynomial, and I'm going to put 0 here instead of p of x. So here's what I want. If you guys get linear factors, you can pull out the zeros really quick, because you guys have already done this. So when will this number right there be 0? When x equals 0. Okay, are you with me? These are called roots, but no, we're going to call them what? Zeros or solutions. When is this one going to be 0? X equals 3. When's this one 0? Okay, so there are your zeros or your solutions. Okay? Then they talked about multiple zeros. There's one 0 up here that happens more than once. Which 0 happened more than once?
Yeah.
2x.
2x happens more than once?
No. What you're asking.
Well,
X minus 3.
x minus 3, it says x minus 3 what?
Square.
You know what? This happens, x minus 3, how many times? Twice. So this is said to have a multiplicity of 2. A multiplicity of 2. Where this one has a multiplicity of what? Look at the x. X to the what? First. 1. Okay.
So then it's like plus 1.
This one also has 1 there, so a multiplicity of what? 1. So how many answers do I really have? How many solutions?
4.
1, 2, 3, because it has multiplicity of 2, 4. Okay? So you have 4 solutions. One of them happened twice. It's called multiplicity of 2. Okay? Relative minimum, maximum, cross it all out. Cross it out. Go to the next page. The next page says the factor theorem. The factor theorem. The expression x minus a is a factor of the polynomial if and only if the value of a is a 0 of the related polynomial function. Okay? Hang on. A lot of the stuff I'm saying to you probably doesn't quite make sense. So can I just clear that up for you? When you look at this one, x plus 1 times x plus 3 times x minus 2. That's your polynomial in factored form. But here's the deal. You see that? See that factor? That came from what 0? Where did this come from? A 0 of what? -1. If you have a 0 of -1, that's your factor. Where'd this one come from? If you have a 0 of -3, that's your factor. And this one should come from what? 2. So that's your factor. So what they're trying to tell you is this. If you guys know a 0, then you guys should know what else? Okay, guys, if you know a 0, you should also know a factor. Right? If somebody told me -1 is a 0, couldn't I tell you guys? Well, then x plus 1 is a factor. If -3 is a 0, then x plus 3 is a factor. If 2 is a 0, x minus 2 is a factor. So by me telling you that, here's what you should be able to do now. If I tell you your polynomial has zeros of 6, negative 2, and 4. 6, negative 2, and 4. What factor did 6 come from? X plus 6, I heard. Is that right? Put it in. 6 plus 6 is 0.
No.
Minus.
Minus. It's got to be a minus, doesn't it? So you guys should be saying minus, right? Ryan Hansen, if negative 2 is a 0, what's a factor?
Plus 2.
Ryan Hansen. Ryan, tell me. If negative 2 is a 0, what's the factor?
2.
No. Christine, what's the factor? Guys, if I tell you this is a 0, then the factor down below has to become 0. So, do you guys, if this is 6, do you guys agree 6 minus 6 is 0?
Yeah, x
Yeah.
plus 2.
It's got to be x plus 2. Put this in, guys. What do you think? Is negative 2 plus 2 0?
Yeah.
Yeah. Okay, if 4 is a 0, Nate, what's the factor?
Negative 4.
Okay, but I think you want to say x. X minus 4. Okay, so what happens here is this. If I start giving you zeros of your function, you know what you can do? You can write the factors down. Okay, look at the bottom one. It says this. What is a cubic polynomial function in standard form with zeros of negative 2, positive 3, and positive 5? So what they want you to do is this. Write out the factors. Just like I just did. Here the zeros are negative 2, 3, and 5. Go. See what you can do. Okay, if negative 2 is a 0,
Is that a 5 or?
it's a 5 on your paper. That's a 5. That's a 3. Okay. So if this is a 0, what factor?
X plus 2.
X plus 2 says Brooke. Taylor, if 3 is a 0, what's the factor? X minus 3. Okay, and Caitlin, if this is a 0, what's the factor?
X minus 5.
X minus 5. Good?
Yeah.
That didn't take much, did it?
Oh.
No. You know what they say? Put it in standard form. They actually want you to FOIL this out and do all that work. I'm not going to make you. I like this form. I'm going to call it what form? Factored form. Okay, factored form is a nice form. It's kind of where we like to be. Okay? All right, turn the page if you're ready. Now what do we see? Ooh, good old multiplicities. Okay, here we go. Now, I can read this all to you. I'm not sure if it's going to make a lot of sense, but I will clean this up in just a little bit. It says, you can write the polynomial function in problem 3 in factored form as x plus 2, x minus 2, x minus 3. Okay? And g of x as x plus 2 squared, x minus 2, x minus 3. In g of x, the repeated linear factor x plus 2 makes negative 2 a multiple 0. Okay, so now they're going to start talking about multiplicity. I already did this with you, but let's just talk slower about it. In particular, since the factor x plus 2 appears twice, you can say that negative 2 is a 0 of multiplicity 2. In general, a is a 0. A is a 0 of multiplicity n means that x minus a appears n times as a factor. All right. Again, that might not have made much sense. Let me get to it in just a second. I'm going to read one more thing to you, and that is how multiple zeros affect the graph. If a is a 0 of multiplicity n in the polynomial function, then the behavior of the graph at the x-intercept, a, will be close to linear if n is 1. Close to quadratic if n is 2. Close to cubic if n is 3, and so on, and so on. Okay? Now, how much of that made sense?
None.
None. That's what I thought. Okay. Thank you for being honest, Skylar. I like that. I like that about you. All right, here we go. Let me try and make this as easy as I can.
Mr. P,
Yep,
you still taping?
I am.
Can you hear us?
I can hear you just fine.
It's good.
Is that good? All right. Okay, now yelling, that doesn't mean you get to start making noises, okay? All right. Hey guys, would you help me out now? What are the zeros?
-3.
-3? Okay, what else?
3.
3. What else?
-5.
Okay, these are the zeros. That wasn't very hard for us. Okay, here, the next question is multiplicity. Multiplicity, if you see a 1 above your factor, it has a multiplicity of what?
1.
1. Pretty simple. Okay, how about this one? 2, next. 3, and so on. Okay. So that's not hard, is it? Here's what they want to know. What does this do to the graph? What does this do to our graph? Well, let me show you. Okay. You have to understand zeros are just x-intercepts. So this is 3, this is a 0, this is -3. Okay, what's the other one? -5, keep going this way. Okay, so here's what you have, 1, 2, 3. 3 zeros. What do the multiplicities do? Let me do this. I am going to go this way. Okay, the graph goes from this point on forever. Now, here's what happens with multiplicity of 1. It goes through the graph, just like a line would. Multiplicity of 1 means it goes right through the 0, and then it keeps going, but it's got to get here. So what's it have to do? It has to turn. So here it goes. It's going to turn. There it goes. Now, as it turns, it's going to go to this 0. But what's it going to do at negative? Where's it go? Here's -3.
1.
Uh-oh.
It's gonna
Uh-oh. Uh-oh. I didn't see something. I got to back up. I'm sorry. This is -5. I should have been over there.
Yeah, come on, Mr.
This is multiplicity of 3. If your multiplicity is odd, it goes right through the 0, but I messed up here because it does go through this 0, but there's a problem. And the problem is this. When it goes through -5, it goes through like this. Little bit slower, flatter, and then it goes down. It doesn't go right through. Multiplicity of 1 goes right through like a line. Multiplicity of 3 goes right through, but then flattens out and then goes down. A multiplicity of 5 would go right through, but it'd be really flat and then goes through. Okay. The higher the multiplicity, the flatter it goes through. Okay, so here it goes through nice and flat, now down. And then it's got to turn and head towards what? -3. But the multiplicity is odd again. Odd multiplicity means it goes through it. And this time it goes through it pretty fast because it's a small number like 1. Then it goes up, 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 and then it starts to do what? Come back down to 3. Now at 3, the multiplicity is even. When the multiplicity is even, it acts like a parabola. It's going to do what?
Bounce.
I like the word. That's it. It's going to bounce and go back up. And there it goes forever. Up, up, up. Here it goes up, up, up. How did I know? How did I know it went up, up? It has to be an even or not. Is this even or odd?
Let's see.
It's even.
It's got to be even to go up, up. Okay, here's the deal. Count your multiplicities. Ready? 1 plus 2 plus 3 makes what? 6. You have x to the what?
6.
6. X to the 6 is even. It's either up, up, or down, down. How did I know it went up, up? Was there a negative in front of my factor? No, I didn't have a negative. I had a positive. There's a positive right here. Okay, so it's up, up. Here's the deal. You just need to know this. Multiplicity of even multiplicities bounce. Odd multiplicities do what? They go through. Now, they go through really fast or really kind of slow, but they go through. This would be a multiplicity of what? 3. This would be multiplicity of what? 1. This one bounced, so this is multiplicity of what? Even? 2. So what's a multiplicity of 4 look like?
Bounces.
It bounces, but it bounces kind of flat. There, that would be a multiplicity of what? 4. What would multiplicity of 6 look like?
Super flat.
Even flatter. It would go like this. It'd come down and it'd be flat for a while. And then it would shoot up. The flatter it is, the higher the number. Okay? Does that make sense? Okay, good. Okay, now look. Oh, you got a table down below. It says this, how multiplicities affect the 0. A multiplicity of 1, in your own words, what would you put? Uh-oh.
Like straight through.
Oh, like that, straight
Nice.
through. Okay, good
Beautiful.
job. Multiplicity of 1,
The way you said it was nice.
I write goes straight through. And when you say through, you mean through the what? X-axis. Okay? How does it affect graphically? How does it look? Graphically, make a picture, guys. Just go like this, put 2 like this, and just show it goes right through, just like that.
Where are you supposed to draw this?
You draw it wherever you want, off to the right. Okay? How about multiplicity of 2?
Bounces.
That's a bounce.
That's a bouncer.
Okay? So then draw a picture over here like this. At 2, comes down, it bounces. Multiplicity of 3 goes what?
Curves through.
Yeah, it goes through flat. Good. It goes through flat. Okay, like this. 1, 2, coming through like this, little flatter, then there it goes. Okay? You okay?
You spelled through wrong.
Goes through. It's T-H-R-U. All right, next up, 14. Identify the zeros, their multiplicities, and their effect on the graph of the function. Okay, take a look at 14. You should be able to do this without my help.
Oh, I was using that. Yeah, I'm just work.
Okay, looking at this function, the zeros are Noah. How about the first 0? Right here.
I was going to say negative.
Say again.
Negative 1.
-1. So if I let x be -1, it will make it 0.
Oh wait, no, it's 0.
0. If you let x be 0, what's -0? 0. It's a 0. Okay. How about 3x minus 2? When is that going to be 0, Caleb? Nothing?
Two-thirds.
Whoa, 2/3? Okay. Here's how you do it. If you go like this, set it equal to 0. Add 2. Divide by what? 3. Look, he got it. Ryan Hansen gets it 2/3. Okay. How about the last one? X plus 9, Dylan? When x is -9. Okay, got it. Okay. Multiplicity. Is that the next one we want?
Yeah.
Yeah. Okay, what's the multiplicity?
The first one.
Multiplicity of the first one is what? Look at your x. X to the what? First, it's got to be 1. Multiplicity of 2/3. It's right here. It's 2. Multiplicity of negative 9. 5. Good? Next, the effect on the graph. What would it do if it was 1? Multiplicity of 1.
Just go straight through the.
Straight through, just like a line. Straight through. How about 2? It's going to bounce off the x-axis. How about 5?
5.
Okay. Goes through though, doesn't it?
Yeah, for sure.
Goes through how? Very. This would be very flat. Okay? That's it. All right, the next one, 15. What's wrong with it?
It's not that.
It's not factored. Guess who gets the factor? Go.
Wow.
Go, go, go.
Sweet.
Once you factor it, pull out the zeros, tell me the multiplicity, and tell me what the graph's going to do. Oops, I forgot an X, sorry.
Yeah, I was gonna say it's not
What did you guys do to factor?
5 and 5. Only know
You
for
just
my-
do x plus 5 squared.
Yeah, but didn't you guys take out the GCF?
Oh yeah.
What's the GCF?
X.
Take out an X. Good, good. Once you take out X, what do you get?
X squared plus.
X squared
10x.
plus 10x, what?
Plus 5x.
Okay. Now you look at the trinomial. What two numbers multiply give you 25 but add up to 10?
Plus 5x
X plus 5x plus 5, right?
Yep.
Equals 0. But could you say it like this? X plus 5 is just x plus 5 squared,
0 and x equals negative 5.
right?
And then x equals negative.
Okay. So what are your zeros? Your zeros are
0 through
Zero.
negative 5.
0 and negative 5, exactly. Your multiplicities are
1 and 2.
Okay.
x to the first, 1,
Yeah, we good.
x plus 5 squared is 2. Okay? If I were to graph it, multiplicity of 1 means it's going to do what?
Go straight through.
It's going to go straight through. Boom. Okay, straight through. How about multiplicity of 2?
Bounces.
Bounces. Acts like a parabola. Okay? Good? Yeah?
Yep, we're good.
Okay, keep going. Go to the next one.
Wait,
The
we're
next
done
one
there.
says a polynomial function has a 0
What about write the equations?
at 4. Multiplicity of 3.
Look, that one.
And 0. Multiplicity of 1.
What about write the
You and that
equations?
one.
Yeah, we're done. We're here.
Oh, you're just. Oh.
Write a function in standard form. Don't worry about standard form, just give me factor form. That could represent this function. And then it says, box in your answer. Okay.
It's right there.
0 at 4, multiplicity 3. 0 at what? 0, multiplicity what? 1. Give me your function in factored form. If you have a 0 of 4, what factor exists? No. Factors are always x minus 2, x plus 7. If 4 is a 0, where did it come from? X minus 4 is where it came from. What's the multiplicity? It's cubed. X minus 4 cubed. And then that one, where did 0 come from?
0.
Like
Yeah, I can't just say 0 though.
just x.
It's always x minus that number or plus that number. Well, what's it going to be?
X plus 2.
X minus 0. Put 0 in. Is 0 minus 0 0?
Sure is.
Yeah, it is. Guess what? You don't even need the minus 0. You could have just put what?
Nothing.
Nothing. You could have just said
Nothing.
simply x. When is x gonna be 0? When you let x be 0. Okay, so, oh, by the way, multiplicity is 1. Put a 1 there. There you go. There you go, that's it. Okay, last one, then we're done. Lower left corner, tell me the polynomial function. Give it just like this. This is what your answer is going to look like when you're done, just like this. Looking at the graph. Look at the graph and tell me what you think. What is this 0 right here?
So,
Is it 6, -6, or is it what? I can't even see it. To me, it looks like -6.
Yeah, I'd say 6.
Okay, what's this 0 right here?
Say
-3, okay.
okay.
What's this 0 right here?
1.
1. What about the next one?
4.
4. The next one? 7. Okay. Now, guys, if you know those are your zeros, you should know the factors of your polynomial. Here it comes. F of x equals. If this is a 0, where did it come from?
X plus 6.
X plus 6. Good.
What's be negative? Will it be negative on the
What's-
outside?
Yeah, it probably will be in just a second. Hey, what's the multiplicity here?
2.
2, because it bounced. What's the next one? X plus 3. What's the multiplicity on this one?
Probably 3.
Yeah, it's 3 because it's flat, right? That's a flat one, yes. We will pick up right there when you get back. Tell your classmates this will be on YouTube in about noon, after lunch.
I'll be back after.
I know.
So I'll be here after school.